Thank you for joining this lesson. We're going to discuss scale drawing. We've been told that 3 points P, Q, and R are on a level ground. Q is 240 meters from P on a bearing of 230 degrees. R is 120 meters to the east of P. Using a scale of 1 centimeter to represent 40 meters, draw a diagram to show the positions P, Q, and R. Therefore, we're going to show the positions of P, Q, and R on the ground. Therefore, I'll begin. Let me get my tools first. Yes. So we're going to begin from, because we are told Q is 240 meters from P on a bearing of 230. It means we are beginning from P. Therefore, standing at P, assuming that P is somewhere here. Yes. Let me use a very straight, that is my point P. What I want is a bearing of 230 degrees. That means this is a true bearing, and a true bearing is measured from the north and in the clockwise direction. Therefore, this is already 180. I'm just going to add 50 degrees. From this mark, I'm just adding 50 degrees. Therefore, this is 50 degrees. Then I produce the line. Yes. I've added 50 degrees here, so that 180 and 50 gives us the bearing of 230. Then now, the distance, again from P to where Q is 240 meters. With 240 meters, I need to divide it with 40, the scale, so that I may know. Now I will measure only 6 centimeters. Instead of the 240 meters, the scale allows me now to use 6 centimeters instead. So 6 centimeters, I produce, this is 6. This is exactly at 6 centimeters. So standing here, I'll make an arc. That gives me 6 centimeters. And now, so that I may raise a very perfect north, now that I had measured 50 degrees at this point, I'll measure another 50 at this mark, but on the upper part. Therefore, I'll need exactly 50 degrees. Exactly 50. This is where 50 is. Therefore, now connecting that 50 degrees mark with the 6 centimeter mark, I can produce my north now. So this is going to be perfect north. This is now my 50 degrees. So with 50 here and a 50 here, these norths are very parallel to one another, and the diagram is very accurate. This gives me the position of Q. That gives me the position of Q. Now with Q, we can get R, which is 120 meters to the east of P. So from P, east of P means just moving to the right hand side. Therefore, I use my compass to just produce 90 degrees from this point. 90. Then I enlarge a little bit. Standing here, I make an arc, and standing here, I also make another arc, and I produce a line towards the east. A line toward the east. that is towards the east. Towards the east we will get R, but now it is 120 meters away. That means 120 meters divided by the scale of 40. I will just need 3 centimeters. So I will stand at the 0 centimeter mark. I measure 3 centimeters and I lift that radius. Standing here, I make an arc. So this becomes now our R. Actually, with R, we can even join it with Q. R and Q. R and Q. Yes, those are the relative positions of the 3 points on the Earth's surface on the level ground. The next thing to do in this case is to respond to a few questions now. Determine the distance R from Q. R from Q, I will need to get the radius. I need to get this radius. Then I transfer it now to my centimeters scale. Standing here, I read 8.4 exactly. So I will take 8.4 centimeters and I multiply it with the scale. 8.4 by 40 to give me 336 meters. So that is the scale. That is the distance. The next is the bearing of R from Q. The bearing of R from Q. So at Q, the bearing to R, I just have to measure this angle from the north until I get the line connecting R and Q, because it is the bearing of R from Q. So I'm measuring from Q. That is the secret. When you see from, that is where you will measure from. So I have to begin from Q. Yes. And I measure this angle, which is exactly 64. Which is exactly 64. Yeah, it is before 65. So this is 64 degrees. So I can simply record it as a true diagram. 0, 64 degrees. Or I express it as a compass bearing, in which case I will say from north, 64 degrees towards the east. That is where R is from Q. So that is the bearing question. We can check another question now, part C, which involves angles of elevation and depression. Then we are told a vertical post stands at P and another at Q. That is according to the Q and P in part A. That is. Then we are told that a bird takes 18 seconds to fly directly from the top of the post at Q to the top of the post at P, given that the angle of depression from the angle at P to the top of the angle at Q is 9 degrees. This is 9. Is 9 degrees. Calculate the distance to the nearest meter between the bird's cover. The bird's cover. So what distance will the birds cover? From P and Q, we saw that the distance was 120. The distance was 120. Then there is a post here and a post at Q, and a bird takes 18 seconds to fly from the top of the post at Q to the top of the post at P, given that the angle of depression from P to Q. Therefore, the post at P is taller. That means we use an angle of depression to see the top of the other one. To see the top of the other one. Therefore, this is one top, this is the other top. Therefore, the angle of depression from this one to where the other one is 9 degrees. That means with a straight line here parallel to the base, we are also going to have another 9. We are also going to have an angle of 9 degrees at that point. So 9 degrees so that we may see the top of the other, or 9 degrees to see the other top at this point. So with 9 and a distance of 120 and a distance of 120, then we can get the distance here, the distance traveled. So the distance traveled now is going to be given by, we apply trigonometry, in which case we will say we need a distance x traveled. We have an angle here. Remember 90 is here. So this becomes our hypotenuse, and according to this angle, this will be the adjacent. This means adjacent and hypotenuse will require the cosine of the angle there. So the cosine of 9 will be given by the adjacent side divided by their known hypotenuse. And to get the hypotenuse, we need 120 out of the cosine of 9. Therefore, the distance there is going to be 120 divided by the cosine of 9. This gives us exactly 221. 121, that is 0.5 degrees. Sorry, 5 meters. Therefore, the distance from this top to the other top is going to be 121.5 meters. The other one is the speed of the birds. Remember, speed is calculated by distance out of time. Therefore, a distance of 121.5 and time 18 seconds, but we want it in kilometers per hour. Therefore, we can convert this one to kilometers. To convert this to kilometers, we need to divide them. To convert meters, we need to divide them by 1,000. Need to divide them by 1,000. Therefore, this should be divided by 1,000. Sorry. To convert 121.5 meters, we need to convert them to meters by divided by 1,000. And these seconds, we also have to divide them to make them hours by 3,600. By 3,600. So this will give the speed in kilometers per hour instead of meters per second. Convert the meters to kilometers by dividing by 1,000. We convert the seconds to hours by dividing by 3,600. Therefore, we need to take now 121.5 divided by 1,000. Then now we divide the answer by 18 divided by 3,600. And this gives us 24.3 kilometers per hour. 24.3 kilometers per hour. Thank you for following. Subscribe and share.